Suppose you're an Airbus A380 pilot in command, planning to fly from Los Angeles to Dubai. Are you going to fly in a straight line over the Atlantic Ocean? In fact, we will fly over the polar region. So why is it like this? The reason is, our map is not accurate. So what is a map? A map represents a curved surface on a plane. Then why is our map inaccurate? Imagine you are floating and unfolding a cylinder. You can always do it without distortion. The distance between the points A and B remains the same. But if you're peeling an orange, you can't flatten it without distortion. There will be some holes in the plane. The idea is the same. You can't flatten an orange peel as if you can't flatten a curved surface to a plane. And hence, maps are always inaccurate. Although maps are always inaccurate, there are some properties that they can preserve. Maps can basically be classified according to these properties: angle, local shape, area, and the shortest routes. I will introduce three kinds of maps which preserve different properties: the Mercator projection, conic projection, and Lombard cylindrical projection. The Mercator projection preserves angles, and hence it is good for navigation. We can see that all the latitudes and longitudes are perpendicular to each other. The distortion is large in the polar region. For example, on the map, Greenland looks roughly the same size as Africa, but in reality, Africa's area is 14 times greater than that of Greenland. The second kind of map is called conic projection, which preserves the shortest route. When we talk about the shortest route on a sphere, it involves the concept of great circle. The great circle divides the sphere into two equal hemispheres. Conic projection maps the great circle from the Earth's surface with respect to the center of the Earth onto straight lines of a tangent plane. Hence, any line segment on a conic map shows the shortest route between the segment's two endpoints. The projection is used by pilots on long-distance flights. Since all longitudes are great circle, they are always shown as straight line in a conic map. And from the map, you may know why Airbus from Los Angeles to Dubai flies over the polar region. The third kind of map is called Lombard cylindrical projection. This was developed by Swiss mathematicians Johann Heinrich Lombard. This projection preserved area on the map. It projects the Earth's surface onto a cylinder with respect to the vertical axis of the Earth. In the map, we can see that Greenland is much smaller than Africa. However, the map is rather compressed and the shapes are distorted in the polar regions as well. So, our final question is, does an ideal map exist? Mathematically, a sphere cannot be represented on a plane without distortion. No single map serves well for all purposes. Using a globe is the only way to represent all geometric properties of the Earth.